In the vast silence of the cosmos, sometimes the universe whispers secrets. Secrets that ripple through time. Secrets that bend space. And sometimes, just sometimes, it feels as if something is watching back. Was that a star collapsing? A black hole forming? Or something else entirely? Something that connects one part of the universe to another? Today, we're diving into one of the most mind-bending concepts in modern physics, a phenomenon that might unlock faster than light travel, time manipulation, or even contact with other universes. This is the story of wormholes. What are they? Are they real? Could we ever find one or build one ourselves? Let's go deeper than ever before, into the science, the speculation, and the staggering possibilities of wormholes. To understand wormholes, we have to change the way we think about reality. Normally, we think of space as a static stage. Stars and planets are actors, and space is the platform beneath their feet. But according to Einstein, space isn't passive. It bends, it curves, it's elastic. It's like a trampoline. Objects like the sun or earth weigh it down. Now imagine you're on that trampoline, and you want to travel from one point to another, across the surface. It takes time. But what if you could fold the trampoline, bend the fabric of space, and bring two distant points together? Then, just punch a hole through. That's a wormhole. The term wormhole was coined by physicist John Wheeler in the 1950s, but the concept dates back to 1935, when Albert Einstein and Nathan Rosen discovered a solution to Einstein's field equations that allowed for a bridge between 2 points in space-time. They called it an Einstein-Rosen bridge. It was purely theoretical, and at the time, most physicists believed it couldn't actually exist. But that didn't stop others from dreaming. Science fiction has long loved the idea of wormholes. They solve a big problem. The universe is too big. Even at light speed, it would take over 4 years to reach the nearest star, Proxima Centauri, and tens of thousands of years to cross the Milky Way. Want to visit another galaxy? Multiply that time by millions. But a wormhole, it's a cosmic shortcut. Step in and instantly emerge billions of light years away. In Interstellar, the characters use a wormhole placed near Saturn by an advanced civilization. Kip Thorne, the physicist who consulted on the film, made sure the wormhole was scientifically plausible. He even published academic papers based on the equations used to simulate it. But here's the thing. While wormholes are mathematically possible, that doesn't mean they're physically real. What would it take to make one? Or even find one? One of the biggest challenges in wormhole theory is stability. Most natural wormhole solutions collapse too fast for anything to pass through. Imagine a tunnel that crumbles the moment you try to enter it. To keep it open, we need exotic matter. This isn't just weird-sounding stuff. It's a real concept in physics. Exotic matter has negative energy density. This means instead of pulling objects together like gravity normally does, it pushes them apart. Where does that come from? There's a real quantum phenomenon called the Casimir effect, where tiny negative energies appear in a vacuum between metal plates. Some physicists believe this is a clue that exotic matter might be possible. But to hold open a wormhole, we'd need huge amounts of it, far more than anything we've created, and that raises a key question. If wormholes require exotic matter, but we don't have any, how could they form naturally? Some theories say wormholes could appear in the early universe during the Big Bang. Others say they might exist inside quantum foam, the chaotic microscopic structure of space at the Planck scale. Maybe tiny wormholes are forming and evaporating constantly, too small to detect. Maybe they're all around us, or maybe there's one out there waiting to be discovered. Here's where things get interesting. Scientists today are actually searching for wormholes, not just in theory, but in the sky. How? Through gravitational lensing. Massive objects bend light. But if something bends light in a way that doesn't match its mass, or if we see duplicate stars that shouldn't exist, That could be a clue. Also, unusual radio signals. In 2021, astronomers spotted strange emissions from the center of the Milky Way. One theory? A wormhole inside a black hole. Still, we haven't found solid evidence, but upcoming missions like the LISA gravitational wave detector and future quantum telescopes might reveal subtle space-time distortions, wormhole footprints. Meanwhile, physicists are simulating wormholes in laboratories. In 2022, a team used a quantum computer to create a toy model of a wormhole. It wasn't a real one, but it mimicked its behavior. Step by step, we're getting closer. Let's say we do figure out how to stabilize one. Could we build a wormhole? Some physicists suggest using black holes or manipulating dark energy. Others think cosmic strings or extra dimensions could help. And there's a wild idea from string theory. Maybe wormholes connect not just points in our universe, but entirely different universes. Multiverse theories propose that wormholes could be bridges to alternate realities, each with its own laws of physics. Would you risk walking through? Of course, building a wormhole isn't just a matter of engineering. It might require rewriting the laws of physics, or at least merging quantum mechanics with gravity, a unified theory we don't yet have. But like going to the moon, what seems impossible now might someday be routine. The truth is, we don't know. It could be tomorrow. A telescope might catch something odd. A gravitational wave might point to something new. Or it could take a century. Maybe we'll need new physics, new technology, or even artificial intelligence that can see what we cannot. But here's the key. For the first time in history, we're asking the right questions. And in science, asking the right question is often the first step to discovery. Wormholes aren't just about physics. They challenge our understanding of time, causality, and reality itself. If you could cross a wormhole and emerge in the past, what does that say about free will? If wormholes exist, do they prove the universe is connected in ways we can't yet perceive? Some believe consciousness itself might one day unlock paths through higher dimensions. Others believe wormholes are how civilizations travel the stars, quietly, invisibly, instantly. Are wormholes real? We don't know. But every major scientific discovery once began with something even more elusive: imagination. The same way we once imagined flying machines, or moon landings, or quantum computers. So perhaps, just perhaps, someone, somewhere, has already stepped through, and one day we might follow.